Okay, we'll start with the question that we were incomplete, or you could say we're given you the to get it done at home. Just tell me how many of you have done, or what will be the answer. Then we'll proceed with the further thing. Question was this. Okay, this was a question. What we have to find? Question was asked. Find Z at P max. Okay, where maximum power is transferred. Okay, this is the question. Now tell me, what will be the value of your Z? Anyone have solved this? Mrityunjay, Shobha, Sudhanshu, Suman, Susil. Anyone has solved this?
No, sir.
Okay, try. Tell me how we could do. Okay, it's a question of maximum power theorem. Okay, what we have to do is we have to find at what value of Z maximum power would be transferred. Okay, to this point. Okay, this is what we have to find. Okay, so how we could do, or how we could proceed with this. So when what conditions we have told you, okay, for P max, okay, the condition that you have to keep in mind is your RL would equal to your RS, right? Your Z would be equal to Z equivalent this. Okay, this is your, let's take ZL. Okay, that should be equivalent to Z equivalent of, right? This is what you have to do. Okay, then another is your XL would be minus of XC. So the three conditions that you have to keep in mind. Okay, whenever these questions would be here, so what you have to find the equivalent of this. Okay, you have to find the equivalent of this circuit, right? So how you could find equivalent? Let's see. Okay, we'll draw this circuit again. That how it would circuit. This circuit would be. Okay. Okay, let's say this is your circuit. Okay, this is the circuit. Now, what you could do, you could normalize this format, and if as you are finding z equivalent, you know what is your z equal in this format, right? So you could convert this particular segment into that particular value. Okay, now let's see what we have. We have this value, that is your 1 by 2h. Okay, so from this what we could find, that is your xl. So what is the formula of this? That is your j omega l, right? So you could write j into 2 into l. What is the l value? This is your 1 by 2, right? So this would be xl would be your j. Okay, this is what we got. So wherever the 1 by 2 h is given, you could convert that into only j, right? That would write j ohm. Okay, this is 1 ohm, this is 1 ohm, right? Now about 1 by 4f, right? So 1 by 4f could be written as into xc. This xc would be equals to 1 by j omega c, right? Yeah, 1 by j omega c, right? So you could write that 1 by j into 2 into, that is your 1 by 4, 1 by 4. So it's 2, it's 2. So you could write xc as j would be minus j and 2. Okay, so your xc would be minus j2 or 2j, whatever you want, right? So these values are being reduced. Now let's redraw this again. Okay, so it will be written as z2, z21, it will be your j, it will be 1, right? This is your ab, right? Now how you could draw this again? Okay, how you could draw this particular circuit, okay, in a better view. Okay, let's see. If we rotate this, if we see, okay, this particular segment is a same one, right? So if we could draw in this particular format and name this as z, let's take z1, whose value would be 1 plus j, right? Yeah, 1 plus j. Okay, and if we stress out this particular segment, you could see these are in parallel with this, and it is connected to this particular zone, okay, to this format. So if we connect this, if we will be connected in, it will be connected, it will be in this, that is your 1 ohm. This box is in parallel, so we'll connect this in parallel. And if we see, this is coming over here and this is coming from here, this is ab, right? Now it will be minus j2 minus j2, right? So we could draw this, we could rearrange in this particular fashion, right? Now you could easily find z equivalent at this area, right? How will you find? This is this parallel with this, and like will do. So how would be your z equivalent would be? Okay, z equivalent would be 1 plus j parallel with 1 plus minus 2j with parallel with minus 2j, right? This is what you have to solve. Okay, this is what you have to solve. So let's first solve this part. Okay, so it's minus j2 minus j2, will write minus j2 into minus j2 by minus of j2, right? So it will be your 4 by minus of j square plus 1 is 4 would be minus 4j, right? So this would be, it will go above, it will be j, right? And this particular okay, where it is, yeah, this particular segment is there, so it will be your plus 1, so we'll get plus 1. Okay, is it will be coming minus of j. Okay, this minus minus plus, okay, j square, so it will be minus. Okay, it will be minus. Okay, minus minus plus, it will be minus 1. So ultimately answer of this would be your 1 minus of j, that is parallel with 1 plus j. Okay, okay, this is 1 plus j and 1 minus j, right? This will be, now if we solve this particular segment, that is 1 plus j 1 minus j, you will get, right? On solving, what we'll get around right, will be 1 plus j0 at a plus b square. Okay, this will be in that particular fashion. So this is your z equivalent value, right? Now if you have to find your like we know for this p max, your z equivalent should be, sorry, your z would be z equivalent star, so it will be 1 plus minus j0 star, as this value is not there, so it will be 1. So your z would be 1, okay, at p max, okay, maximum power. This would be your this term, right? So we'll see another question, then we'll move to the other kind of questions. Okay, so I need your answer from this. This is one question. Okay, this is same thing. You have to find the value of RL. Okay, the condition is when the power should be maximum, whether the transform of power should be maximum. Okay, this is, I will give you more detail of this. Okay, fine. This is what, okay, tell me the answer. What will be the answer, how you could solve this? Okay, condition, you know, it is to find the RL when it is your maximum power is transferred. Okay, for p max. Okay, what will be the value of RL? Tell me the answer. Is 0.5 I1? Okay, it's 20 ohm. This is RL. This is 40 ohm. This is 50 volts. So how you could find? You have got the idea at least that you have to find the R equivalent value. Okay, so you have done Thevenin's and Norton's where this kind of questions are there. Okay, with dependent sources. So in that case, what you are gonna do? Okay, so tell me. Anyone can provide me any lead? Are you all practice doing or?
Yes.
Okay, better. So I will help you out meanwhile to others, so it will save the time. So what you have to do, you have to find R equivalent, okay, when dependent sources are being given. So it will be 0.5 I1. Okay, RL would be not there. We could eliminate that particular segment, and if we sort this, so it will be kind of this. It will be 20, it will be 40, and you, when the dependent source are there, so what you have to do, you have to bring up a 1 volt of voltage right now. So there is a small segment, okay, I don't know how you would be following. Okay, the sign conversions are very necessary, how you are seeking and how you are considering. Okay, as in this you could see the initial direction are in upside direction, and this I1 is given in this one direction, right? If I have taken this 1 volt, so if I'm telling, if you are considering in this point, that is your I, okay, which currently been going, and you know the voltage drop across all three would be same. So if I consider at this particular point, so at this point also you will have a voltage drop, okay, that will be same. Now, so how you are going to be proceeding, that is very necessary. If I am considering this particular point, if I want, I will not follow the sign convention what they have given. Instead, I would be following that all the current which are flowing through that particular segment. I'm considering for what? For writing that equation only. Okay. So in this particular fashion, I will write this. Current is going in that direction. Current is going in that direction. Current is traveling in this direction, right? And current is, this current was what? This current was your I1, right? This current was I1. You could see it is flowing through the 40 ohms. So I am also traveling, asking them to follow in that particular direction. So it will be on 40, right? And one current would be following in this. So this will help in the writing in the equation. Now, how would you write the equation? If I will consider this particular, it is in opposite direction, so we will write 0.5 I1 with a minus signal, right? Why? My current is in this direction and this current is in a opposite direction, right? Then there will be 1 minus 0 by 20, and then again there would be a 1 minus 0 by 40. Then again there would be a one particular current, that is your I. So you could write this as these are in opposite direction, you could write in this I equals to 0. Okay, I got your one equation. Now how you could solve this? On solving this, you have to find the, okay, let's take as equation 1, right? Now similarly, if we see only this particular segment, or if you only see ohm, right, current is flowing, that is your I1, and drop across this and this point is your what? Is your 1 volt, and ohm, your resistance is your 40. So your I1, what will be your I1? I1 would be your 1 by 40, right? What you have got at this particular point also, right? So this would be your equation 2, right? Now, so similarly, on replacing this value on over here, let's erase this. Minus is this. Okay, if we put this value in this this equation, okay, it will be minus 0.5 into 40, okay, plus 1 by 20 plus 1 by 40 would equals to your what? I1. Is it? So you could find I value in this particular fashion. What will be I value? Let's take 40. So it's minus 0.5 plus 2 plus 1. So I would be 2.5 by 40. Is it? So whatever will be value, that will be your I value. Now, what is your R equivalent over here? R equivalent would be your V by I. So V is 1. So I value will be your into 40 by 2.5. So whatever value you are getting, that will be your RL. R equivalent. So whatever value you are getting. Okay. Let's see what value would be there. 400 divided by 25, that is just 16. Okay.
16, sir.
Yeah, 16. This is the answer. Okay, so this kind of question would come, okay, for this part. It is very it's not a time consuming thing, you could easily do so. Okay. Okay, so you could practice more of this kind of question in your maximum power theory. Okay, let's see to the another topic, that is your, we have, or you may have studied this, that is your reciprocity theorem. So can anyone say what this theorem state? Okay, can anyone say what this state, this theorem state? Anyone?
Yes, sir.
Yeah, tell me.
If the terminals of load and source are exchanged, then the ratio of response and input is constant, sir.
The response of your
Response by input is constant, sir.
response by input is constant. Okay, so uh, if I could say, right, like this theorem say that your position, if your position of your excitation and response are interchanged, right, that is, if I draw a particular circuit, okay, this is your source what you're providing, and this is your response, okay, and this is your excitation, right? If this your position of your excitation and response are interchange, okay, your ratio between excitation to response is constant. This is what you mean, right? Is it? Or I would more simplify this format. Okay, if you are measuring at this, if you are supplying, okay, your source is at this particular point and you are taking your current at one particular point of your circuit, okay, so whenever your source is interchanged and at that particular portion you are measuring the current, it would be same, there will be no change in that, right? Now
Sir, is it applicable in several sources, sir?
in several source, no, I think so it is applicable in one particular source only. Okay, single source, it is
Okay,
applicable
sir.
for single source only, right, not for multiple source. Okay,
Okay, sir.
we could, so you gave me another word as well, so we could write this theorem, okay, if there should be linear, right, in a linear bilateral, this is your invertebrate thing, okay, in a linear bilateral single source, okay, this is your single source network, okay, the ratio of the excitation we could say the source station to the response, okay, is constant. When the position of excitation and response are interchanged. Okay, response are integer. Okay, so the basic of this symmetry of your impedance and admittance matrix. Okay, if we see impedance matrix, your Z, okay, Z11, your Z21, Z31, Z12, Z22, okay, this one. So we know V equals to what? Your Z matrix into I matrix, right? Now, so what will happen in this is for a network, okay, where the position of your excitation response are not changed, okay, for this particular format. Now, when your network, okay, when network is reciprocal, okay, when your means you are changing the position of that, so these values, okay, these values get changed. Okay, so that account, your Z21 would equals to Z12, Z31 would equals to Z13, and Z32 would equals to Z23. Okay, from the same circuit. I mean, for this means this particular segment is valid for your reciprocity theorem. Okay, this is valid for your reciprocity theorem. So this is your for original circuit or original network, and this is for your reciprocal network, where you have interchanged these positions. Okay, so if you have a this particular kind of network, so you could check this whether it is being satisfying or not. Now, so if you have to verify this theorem, okay, so to verify this reciprocity theorem, okay, the basic configuration of the network, okay, remains same. Okay, the basic configuration of this entire network remains only the external condition, okay, such as your excitation and responses are interchanged. So this is a keyword that you have to keep in mind. Okay, so if that way I draw this kind of network, okay, so this is your network, only what you are changing is the outer segment, okay, be it A, be it E, or it get interested. So the basic configuration of this particular network do not get changed. Okay, so what we'll do is we'll seek this part. Okay, now we'll do one or will not do because this comes only for a few of the segment in this. Okay, not more than that is coming in this. Okay, now, so these theorems are not valid, right, as per the theorem itself, the description what I told just before. Okay, that it is valid, it means a linear network we are talking about, so it is not valid for non-linear. Okay, and we have talked about bilateral networks would be there, so unilateral networks are also or is not applicable in that. Okay, unilateral or network or elements. Okay, and it also not valid for multiple independent or dependent sources. Okay, as you have stated in that, it is valid for one. Okay, So what that actually respond, like if we are writing with the excitation and response, so that could be written in the simpler manner. I could write that will be V and I. Okay, let's take I1, and when you are replacing that, okay, or you interchanging your position of that, so it will be your the ratio of E by R, that is your V2 by I2, that would be same. Okay, the ratio should be same. Okay, this is the actual, not I made a mistake. When we are measuring at that end, so this should be 2, this should be 1, this should be 2, and this is 1. Yeah, ratio of excitation and response of, when we are considering these two circuits, should be like this. Okay, and the under condition, if the matrix is of 2 into 2, okay, your Z12 would be equals to Z2. So this should be valid, okay, for a 2 into matrix or 2 into network segment. Okay, so this is applicable for your that segment. Okay, so we'll meet in next class and we'll go ahead with this. If you have any problem, you can send me. I could send you answer in offline mode, or you could discuss in this particular segment. Okay, we'll try to do more and more numericals instead of explanations. Okay, we'll bring some of the numerical in next class. Fine. So thank you for joining. We'll meet in next particular class.
Thank you, sir.
Thank you, sir.
Thank you for joining. Yeah.